Okay, so in this video, we're going to take a look at angle bisectors and what they do to a triangle. So cut out the triangle. That's kind of the first task because it's much easier to do this if the triangle is actually cut out. Fold the triangle in half at each vertex, cutting the angles in half. So I literally want you to, as closely as you can, I want you to fold this side over to this side and literally cut the angle in half. The vertices are at the bottom might not match up. That's okay. I want you to fold the angle in half on all three angles. So as you can see, it should create this line that's going to kind of shoot off through the triangle. Using the corner edge of the paper, line up the edges of this paper and the triangle so that the center point is visible next to this paper. Then draw a line. This line is perpendicular to the side of the triangle. So what I want you to do is, if you use a piece of paper, what I mean by that is literally I want you to put a piece of paper so it's lined up on the bottom edge, and then so that you can see the center on the side, and then just draw a line straight down. And do that for all three sides. So you line your piece of paper up here, draw a line straight down. And you can do this with a ruler too. Line your piece of paper up on this edge. So this is literally where the bottom of your paper is. And you're using the edge, the straight edge. And we're using a piece of paper mainly because it's got a corner on it. So it's pretty easy to use that. So I want you to draw the perpendiculars to these. What do we notice about the lengths of these? Because we're going to take the measurements. So I see I have 2 inches here. And I have 2 inches on the next one. And what do we think the last one's going to be? Guess what? It's 2 inches. Okay, so yours might be slightly different. Just depends on how your paper was printed, or maybe if you're using a different triangle, because you can do this with any triangle. It doesn't have to be this triangle. So if you're drawing your own triangle, be very neat about it, okay? Because it can't be wiggly lines or anything like that, and it needs to be very nicely folded for this to work out correctly. So hopefully we've noticed that all of our sides are the same. They might not be 2 inches depending on the triangle you're using, but they should all be the same. So what do we call this point at which the angle bisectors intersect? Well, we call this the incenter. So we had one video that was called the circumcenter. That's where the perpendicular bisectors intersect. Where the angle bisectors intersect is called the incenter. So just a different type of center. So it's not quite the perfect center of the triangle, but it gives us a center point for certain pieces. So the lines coming off of this incenter that are perpendicular to the side are congruent. So the incenter formed by the angle bisectors is equidistant from the sides of the triangle. So it's equidistant from the sides of the triangle. So we can see another example here. They're all 1.9 on this one. And you can see again they folded these angles right in half. They have a dotted line going right through the center of these angles, coming down, and where they intersect, that's where the incenter is. So that's where we measure to the side. And whenever you measure a distance, it should always be perpendicular to what you're measuring it to. Okay. All right, so let's go ahead and use this one. So the angle bisectors of triangle ABC are AV, BC, BV, and CV. They meet at a single point V. In other words, V is the incenter of triangle ABC. So they've already marked it for us here, right? So here's our angle bisector. Okay, so I'm showing you those are our three angle bisectors, and they create these equidistant lengths, right? So I already know these three are congruent. So the first thing they give me is SV is 12. They tell me that AV is 21, and I filled this one in. We'll come back to this in a minute. And they also told me that SAU, so the whole angle is 42, and that UCV is 18, so just this little part down here is 18. So if you notice, I did fill this one in, so that animated a little quickly before I even had everything filled in. But that's because TV is another one of these, the pink lines, right? That's one of my distances there. So I already know if one of them is 12, they are all 12. So if they would have asked me VU, that would also be 12, or UV, either way. Dang it. So now let's take a look at our angle here. So they want us to find UCT. So UCT, they want us to find this whole angle on this side. Well, if UCV is 18, remember this is an angle bisector. Bisector means to cut in half. So if half of the angle, the whole thing, is 18, the whole thing is just 2 times 18. It's just 18 and 18, right? So 2 times 18 is 36, or you could say 18 plus 18. Either way, you'll get 36. All right, so TBV, so let's go TBV. So that's this little angle up here. So we're going to have to do a little bit, something slightly different on this one, because I know the whole angle down here is 42. We just found out the whole angle down here is 36. Now they want half of the angle at the top. So what we're going to have to do is use the triangle angle sum theorem, because I need to know what the whole angle is, and then I can divide it in half. Okay, so we're going to do the angle at the bottom there, that SAU, that's 42 degrees. And we're going to add this angle on the right side here, which is that 36 degrees we just found, and then the angle at the top, TBS, the whole thing. So we're focusing on the whole thing for just a second. So I have 42 plus 36 plus that angle of TBS equals 180. All 3 angles of a triangle always add up to 180. That's always a rule. Okay, 42 plus 36, we get 78. And then I'm going to subtract 78 from both sides so that I can figure out what's left over. So angle TBS is equal to 102. Remember, that's the whole thing, TBS. It's the entire angle. They're only asking us for part of the angle, half the angle, right? So we're going to cut it in half. We're going to divide by 2, and that's going to give us 51. So angle TBV equals 51 degrees. All right, so that was using the incenter of a triangle to find some missing lengths or missing angles. I hope that helped, and I'll see you on the next video.